So it's the start of class, so I'll go ahead and get started. Before we get too much into like other other things, I want to go over a string some more, since I seem to have shown a lot of strings commands only once, and people were having trouble remembering what all the stuff you can do to manipulate strings are. So I'm going to go ahead and just go over chapter 6, which I skipped because I figured you guys could look up string stuff on your own, but honestly it's best for this class that I go over a bunch of stuff we can do with strings. So this is the chapter that would typically go over slicing, but there's a lot of stuff that we can do with strings, and a lot of different ways we can render strings in Python. The first is, I keep forgetting that I can't use the scroll wheel here without losing my place. Let's see. So we went over escape characters, right? Which actually in Python ends up being less of an issue, right? If I've got s is equal to hello, or he said hello, then in order to actually print these quotation marks, I have to put the escape characters in, so that it renders that way. This is true for the single quotation marks too. If I want to do s is equal to he's, if I use single quotes over here, right, as my delimiter, and I do he's there, then I need a escape character for that, so that I can go like that. And of course, because Python is smart, it renders it with double quotation marks when it prints it out. Okay. Let's keep going. And if you put in something like this, print a word per line, it will render a word per line. Nothing too substantial there. So the big thing that's new, and I am super uncomfortable with, because it goes against everything that I basically learned when I was programming, are raw strings, which is having an R the R glyph before a string. And what it does is that it literally renders it for you. It ignores all the escape characters, and it's just a string of literally this text. Okay? And it's useful for, this is useful if you want to, basically it treats all backslashes like they're normal backslashes. You can't really do any escape characters in it. For regexes especially, because regexes uses a lot of them. So the example is putting, and actually let me open this up in idle because it'll be more colorful that way, and color is better. Print R, and notice how as soon as I put a quotation mark there, it was okay with it. The cat got it now. If I do this escape character over there, it prints the cat's got it now, which is really weird, even though it prints that backslash in there too. So raw strings, what they're useful for is when I have to do a regex, if I'm looking for a regex that looks for a social security number, right? I can just go /d/d/d dot dash dash /d/d dash dash, not dash dash, but one dash /d, right? And that'll be a social security number, and I only need one backslash for each backslash. So raw strings are a way to get around backslashes, and when we go over regexes as the next thing after we're done with this chunk of assignment, it'll be good. Now regexes I want to go over next because well, if I boot up Word, you'll be able to see that let's see, you can find, let's see, actually I haven't used Word in forever because I don't use Word. Advanced find, more. Let's see, sounds like Japanese, special formatting, use wildcards. There should be a option over here to be able to find stuff that matches regular expressions. So what does use wildcards do? Special. Actually, I have no idea how to use Word, so that was a silly example because I don't use Word. But I believe there is a way. Regex in Word. Find and place in. So let's see. If you don't see the wild, yeah, is there a way to search in MX? Control H, enable wildcards. So there you go. So I guess because regex would look scary. So that, but if you can use regex in a Microsoft document, that will like seriously make your life easier for you. All right. So the other cool thing is this feature, which is multiline strings, which is what I showed you with 3 quotation marks, right? So, dear Alice, Eve's cat has been arrested for catnapping, cat burglary, and extortion. Sincerely, Bob. Right? And by using multiline strings, I can use 3 quotation marks and everything in between it. You know, is rendered as a string. Right? There's really no need for it. Or really no need for your escape characters. You can just render whatever you want. It's not doing it because it's indented. Oh, yep. Good call. Oh, and I need... See, and it just prints out exactly as I've rendered it. This is pretty cool. But they also serve another feature, right? We've mentioned that you can comment your code using the pound sign. So print hello, or I guess the hashtag now, and it will ignore this, just like we mostly ignore hashtags, right? So, but if you, in actual code, like if we open up a, you can use the multiline string also as a multiline comment, which is actually pretty interesting. It's a very interesting use case for it. So if I go into my, let's see. Yeah, so classroom, get too many folders now. Here's a Python. Like if I go open up our turtle dot program, which we copied and pasted previously, and if I run it, right, you know, I can comment it and say right over here, and you know, I can just insert a multiline string, and it'll be basically treated like a comment if it's just hanging out there, which is nice and useful if we want to, and it just runs just fine. So you can use multiline strings as a multiline comment, which is pretty nice. But they're also another way of just being able to render a lot of strings. So here again, here's somebody else. So this is test Python program. It was written by the author of this book. This program was designed for Python 3, but not Python 2. Right? Here's a multi-line. I keep forgetting that. Go view, show pages continuously. This is a multi-line comment that you can indent inside of a function to explain what it does. So we've also explained how to slice strings. And I think I mentioned this a while ago, but we can also use the in and not in for strings as well, which is very if you remember, we were doing that val assignment. So let's call this InString.py, right? And we had a def count num vowels, right? A number of assignments ago, right? And that would take in a string, right? And we would ask basically we'd have a count equal to 0, and we'd return count at the end, right? And what we could do is that we would basically, the way we probably solved it initially was for each letter in the string s, if letter equals a or letter equals e and so on and so forth, right? And it was tedious to type out that way, and then we would go count plus equals 1. Well, there was an easier way. Well, we can use the in statement as kind of a Boolean thing as well, and we can also use it for lists as well. It's worth reiterating, right? I can create a vowels variable, right? This is all the vowels: a, e, I, o, u. Those are all the lowercase, and we're just assuming everything's in lowercase. Okay, and then I can ask, hey, is this letter in vowels? Right? And if this single letter is in the vowels, just to show that it works, I will use print to debug it. Print found then comma and then letter. Right? I can use comma essentially to put in spaces. Count num count is equal to count num vowels, print count. Okay. Oh, s is not defined. Oh, I didn't give it a variable, of course. Words are cool. Right? And then, let's see, if I run it, and I'm going to actually stop using idle in a bit, but it found O, it found A, find E, O, and O, right? So you can use the in statement to basically ask if something is in something else. All right. So that's enough idle. So I'm going to start... So I'm going to start by using an IDE. I'm using PyCharm now, just because we can also start. You can start looking at a different tool, and PyCharm. Let's go ahead and open my project. So actually, open recent, intro to Python. Let's go ahead and open new. So here's all the code that I've been doing so far. All right. So, what do we need? So let's go ahead and look at more. So we've got all these examples that we can do. We've got hello in hello world. We've got, right, hello in hello world. That's true. Hello in hello. That's true because they're equal to each other. All capital hello in hello world, right? We're case sensitive in Python. And most sane systems are case sensitive, which explains Windows. Why it's not case sensitive, because Windows is one thing that you should know when we're working with file names in Windows. It's not case sensitive; it doesn't care. Is the empty string in spam? Yes, it is, because there's that's kind of like the multiplying by 1 operation there. Cats not in cats and dogs. False. Cats is in there. So there's a whole lot of methods in that strings have access to. I use the term methods rather than functions here. So because they're objects, but honestly, when you hear methods and functions, you can pretty much use them interchangeably. But methods specifically refer to these things called objects. So let's go ahead and open up the file I was working with, which was the InString example. Right? Can everybody see it, or should I increase my text size a little? What? Okay. So, right. One of the issues is that basically is that if I do A-E-I-O-U over here, and I run it, it finds 5 vowels. It doesn't care about A-E-I-O-U. Okay, it doesn't really care. Like, it doesn't know the A-I-O-U. Now, I could do A-E-I-O-U over here as well and look for, capital A's and lowercase a's. Or I can use one of the functions built into string. You can take any string and make it uppercase or lowercase by doing lower. So s.lower. So if I say s.lower is equal to, so if I take the string and run lower, it will turn it into lowercase. And putting it in S stores it back in S. So we've replaced our old string with the with one that's now lowercase. So now if we look at our console, words are cool, A-E-I-O-U. And now it finds A-E-I-O-U because they're all reduced to lowercase. Okay. Similarly, there's an upper, which will now shout it at me, right? But of course now it won't find any because it was converted to an uppercase string. Now, right, here's their example. Spam is equal to hello world. Spam.upper, hello world. Spam.lower, hello world, right? It doesn't change the string itself. So the important thing is that, notice that it doesn't change the string itself. It returns a new string, right? It creates a new string. All these methods will create new strings, just like slices create new strings. Right, and this is a way that basically that you can avoid having to deal with capitalizations. There is an is upper and is lower. So the value is true if it has at least one letter and all the letters are uppercase or lowercase. So, for instance, hello dot is upper. What did I say wrong? Did I capitalize it when I didn't need it? Yep, that's exactly what I did. Hello dot is upper. False. Hello in all lowercase dot is lower. That's true. Hello with a question mark dot is lower is true because all the letters, which were the relevant characters, are lowercase. Right, and I have no idea how this would work for non-ASCII characters. So let's see. Let's go ahead and say dot. But let's find out. It's okay to admit that you don't know how something works. Let's see. So I think I have. We can switch it to. Let's change it to this. Okay, and just go with des. So just simply des. Right? False. Kind of makes sense.
Is it uppercase then?
That is an excellent question. False. I think the idea is that if it has lower cases, right?
Can you say is ASCII?
Dot S dot. So S dot is alphanumeric. So let's go ahead, right? So let's go ahead and try this one. Dot is alpha. So when you have questions like this, string dot Python 3, right? So we'll talk about the standard types. So here it says string. Oh, assuming I can spell string correctly. So now, let's see. There we go. String methods. And it just lists them all in an alphabetical order and goes on about them. Is alpha returns if all characters are alphabetic and there's at least one character. Alphabetic characters are those defined in in the Unicode character database as a letter. Note this is different than the alphabetic property defined by the Unicode standard. So turns out there's when you're dealing with multiple text or Unicode, there's always a little bit of a thing. Like notice that it says that it's different than what it defines as alphabetic, as a letter. So Unicode is derived from ASCII, and I can send you guys a pretty good video link about Unicode. And it's important to know about Unicode, but it's the reason we can actually that computers can actually now talk to each other and then when I send you something, it's the reason that when I go onto the internet right now and I search hiragana, okay, and I go to the Wikipedia page for hiragana, that I don't get gibberish. I actually get this. This renders okay. That I no longer have a bunch of question marks or, box question marks, which you probably remember from like 10 years ago or something, right? Right? I actually get things, and I get the weird pronunciations, IPA pronunciations, properly rendered as well, right? What is this? That's not the voiced velar fricative. The velar nasal. Okay, those are weird symbols, and they're all rendering just fine, right? And I can copy it, okay, and I can paste it into here, and go upper and see what happens. And it uppercases it just fine. Yeah. Yeah, because I'm not dealing with I'm dealing with weird text. It's also how you get those weird Zalgo text as well, So, and I can paste this in, right? And it renders, because it's just using weird text. There's a lot of hacks that can happen in just and by hacks I mean the traditional trick term, not the I'm hacking your computer, although that can happen as well. You've probably seen, hey, if you get this text message, it crashes your app, kind of thing. And where that's because there's a rendering bug that people are basically sending you a message that has a whole lot of text in it. Right? So anyway, that was an interesting diversion. So there's an is upper, is lower, which are Boolean. There's an is alpha, which is considering only letters and not blank. Is alnum, letters and numbers. Is decimal, which lets you say, hey, is this only numbers? Is spaces, is it only white space? Is title. Ooh. Oh, that's a useful one. It returns true if the string consists of only words that begin with an uppercase letter that are followed by lowercase letters. So this is title case is title, returns true here, right? Because notice that it's like a title, although the lowercase is, I think, should be lowercase. This is title case 1, 2, 3 is title is true. This is not, the not is false. This is not, the title case either is title false because you've got all caps for one word. So that's that seems like a really interesting use case, and that's useful that's built in. Okay. All right, so there's also starts with and ends with. Hello world starts with world. That makes sense. Hello world ends with world exclamation point. That's true. Right? And it works again for anything that's non-Unicode. We can let's go ahead and basically copy paste ends with, and then I can steal the Su character. And sorry if your Japanese happens to be worse than mine, because mine is quite terrible. But anyway, we'll take the last character and throw it in there, and hey, it matches just fine. So it works not only with Unicode character, not just with English, but with Unicode characters. But it makes sense. Des ends with des, or let's see. But you can try it out on your own, and this is actually useful to know because if you're, here studying in Japan, the chances are you might be looking to work with a Japanese company, which means you'll have to work with Japanese text, which means it's good to know that all the programs you're working on will work with Japanese text. Okay. So starts with and ends with ABC 1 2 3 ends with 12. That's not going to work because it ends with 1 2 3. So it's looking looking reverse. Do you have a 2 here? No, we do not, so it's false. ABCDF starts with ABC 1 2 3 starts with ABCDEF, so it looks at the A. It goes okay so far. B, that's okay so far. C, that's okay so far. But D and 1 are not the same, so no. With the ends with, it's going to look at the exclamation point, the D, the L, the R, the O, the W, and it's realized, oh, it's done. We have all the characters there, so end with it. Starts from the beginning and just checks it character by character. That's really how it figures it out. Or maybe it does something clever, but at least in theory, that's how you do it. So the join and split methods. The join method is useful, right, when we want to join together a bunch of stuff. And it's weird because it's like the reverse of the way we expect it to look at. It's called on a single list of on a single string, and it gets past a list of strings, and it returns a string. So let's go ahead and create a new Python file, and we're going to call it, I guess, come together.py, right? Which what we're going to do is that we are going to show I'm going to show how we join some strings together. So let's go ahead and create a list of words. This is a list of, gotta remember to put my quotation marks, of words see, and we can switch it. Nihongo, right? The only reason I think that means Japanese, right? Nihongo. I get it right? Awesome, because I don't know kanji, although I do know what this is, so that's good there. So I'm just kind of going to show that this works out just fine, regardless of, again, what I'm using. So so this is my list L. This is my list of words L. So if I could do space.join, let's go ahead and say output together is equal to empty string.join. This is a list of words. So notice this is a list of words, right? And one of the issues we've had was basically if I take this and I print, if I turn this into a string, right, it doesn't necessarily do what I want it to do, right? It renders it, this is a list of words as a string, right? It turns the list into a string. which it gives me a string representation of this. But but if I want this all together as like one thing, all the strings in here joined together, that's not the way to do it. Instead, what I need is to use the join method. And it works like this. You have the space, and then we do dot join L. And then I actually need to print my result together. Let's run that. This is a list of words, Nihongo. Okay? Now whatever I put in here is what's going to be it's what's going to go in there. So if I put a dash here, this is a list of words, right, with all the dashes. Make sense, everybody? If I put in 3 bangs together, also notice that my font just did something interesting there. It's because I'm using a special font to render this. So I put 3 exclamation points in between here. And again, if I switch over to, yep, I'm using font ligatures. And then if I do this again, if I use the, let's see, ooh, this gives me a lot of interesting things. But I was looking for. Yeah, I was looking for the long vowel symbol, essentially, in katakana, but I'm not really sure how to render that on a computer because I've never tried it before. Right? N dash? M? You know what? I've got it now. So, yep, enter once. And now, all right, now I have to switch it back here in order to run this. There we go. And it doesn't matter again. So strings are strings. We don't care in Python 3. Python 2 we'd probably care a bit. It actually and in other programming languages it actually really matters and makes a huge difference. But the more modern your programming language, the less you have to worry about text. This is why I'm also teaching you Python because you guys are going to be working a lot. There's a good chance you're going to be working with Japanese characters, right? And so it's probably very good that these things will work. So whatever you put in here, it's going to go in between everything in this list. Okay? Okay. So now the reverse of that, of join, is the split operation, which I've shown you before. So if I print, so let's go ahead and just show with this example. So now if I create a new variable called apart and I do together dot split, you split it, so you can provide it with no variables, or you can provide it with one thing. And if I provide it with the character we just used to put things together, if I split it along that, it's going to create a list where each element is basically separated by that character. So give you an example. It says, so it looks at this, and then it says, there's the dash character. I need to split this up according here. So I'll stop this, and then I'll start, then the next element starts right after that. Is a list of words, Nihongo. Now the important thing is that it looks exactly for this pattern. So here it's looking for 2 dashes as what you use to split something up with. And so it's going to just produce one element altogether because it just was looking for one. Let's see. Let's see what happens if I do this. Can I use... Nope. Okay, so it's just looking for that. If I split up by spaces, right? Now, traditionally what happens is that you join things by spaces or you split something up by spaces. And if you leave it empty, like this, then it'll also split up via white space. Split will remove stuff via white space. So all new line, so notice how the new line got removed in there because it removes, because without any, it just looks for tabs, new lines, and spaces, and it says, ah, that's your delimitator. So your most common split operation, and the one you're going to use in your you're going to end up using, is either using this, a single space, or the comma, right? Because if you're dealing with comma separated values, which is an easy way to export your Excel files if you don't want to deal with importing whatever you need for Excel. What if I wanted to separate both commas and white space? That is an excellent question. Let's see. In that case, you have to use a regular expression, and I believe and we'll get into that. But you have to use a regular expression. I think you have to use, there's a split method in regular expressions. Yeah. Yeah. Well, what you could do if you were using a regular expression, if you want to do what? Space or comma? I think that would work. I have to double check. I mean, I have to basically, but we can use brackets. But the splitting is pretty useful, and we use it a lot in files because what we'll do is that, like, if you want to analyze everything line by line and then word by word, you can do that. Okay. Now, okay, here's another comma is to take a multi-line string and split it into individual lines, which is a lot of times what we do. So, like, here's their example over here, right, which I'm going to go ahead and just copy into here, right? Now, you may be wondering, let's see. So, spam is equal to Dear Alice, how are you? There's a container in the fridge. It is labeled milk experiment. Please do not drink it. Right? Sincerely, Bob. So, we've got that. And now if we print spam, right? Of course, again, we're dealing with a multi-line string over there. Let's see. Oh, right. Can't split along emptiness, so we've got this print spam. Okay, so another thing we want to do maybe is also do spam.split, and remember this is returning a new string, and we're going to split it along new lines. So if you read in one string and if you read in the file all at once and you want to split it up line by line, you can split by the new lines. Dear Alice, how have you been? I am fine. There's a container in the fridge, right? And notice that basically each line is there. Notice that we have an empty line here, right? Because we have an empty line over here. So it's split over here, and it says, okay, I'm going to read up until there's a new line. Okay, I didn't read anything, so we put an empty element there. So see how since there's an empty line and we're splitting along new lines, there ends up being nothing there. Okay. So now this is a useful thing that I wasn't really too aware that existed, but I am happy that it does. All right. And this is how to justify your text, how to make your text look nice, which is very important. I will never test you on this. It is just useful to know. So let me pump. Now I'm going to just push these right into idle. Okay. Hello, rJustify 10. It justifies it. So how many characters are there? 1, 2, 3, 4, 5, and then hello is 5. So notice that it's got 10, and there were 10 characters, and it justified it to the right? So right when we're dealing with all right. So one of the reasons I don't work with Word is I hate having to do like formatting like this. Like, oh gosh, I need an address. Layout. I mean, okay, don't get me wrong. Word is great. Just like any other program, you have to learn it. It's just that I have been working in LaTeX forever. Oh, right, justify. My name, my address, line 2, and then let's go over here. Then I have to format that to whom it may concern. And then amazing business opportunity. Got to do some bad spelling in there too. Sirs, I am happy to inform you that you have won a foreign lottery with a prize sum of 10 million US dollars. Please gladly send me all your bank info so I can wire you the money. True scam, by the way. It works too. It's actually so. But you know, formatting is a nuisance, right? And then if I have to just tweak it just a little bit, right, to get it just right, I need to I have to do some things. And especially if you're trying to print. Now imagine you're just trying to do this and print out like a table of data, right? Suppose I've got a lot of numbers here. Import random. Let's see. So we never went over random numbers because we really aren't having to use them too much. So random dot next int. Let's see. How do I do? So random dot. Nah, you don't need to seed it. Random dot Python. Oh right. I'd have to create a new random number generator though. Right. So so let's go ahead. So let's go ahead and make a new module. New Python file. Justifying randomness, right? Because random numbers are a good example for justifying stuff because they're all going to be of different lengths. Okay, so import random. So random is a pseudo-random number generator, which gets into this whole philosophical discussion about what is actually random. If I throw some dice into the air, since it is a deterministic event that you could technically calculate how the dice land based on how I throw it and the ways the dice are facing and the angle and the air pressure and all those little things, technically that's not random, that's completely deterministic. So is there actually anything at random? And actually, is there free will at all in the universe, right? Because I'm just electrical circuits going on inside of a head over here. But so that gets into an interesting discussion that computer scientists generally just bang their head against, and they're like, well, if it's distributed in a statistically random manner, we're not going to care about it. So random gives you pseudo-randomness, which is not completely random, but it looks close enough. So that's what matters. Now it uses a scary words like normal distribution, or Gaussian distribution, or uniform distribution. All right, so let me go ahead and just talk about these two random distributions, just de-scare you from a bit of math. Okay, a random uniform distribution just means that if you've got a bunch of random numbers in a range, right, from let's say 0 to 10, okay, or let's go with actually 10 to the 10th power, so a lot of numbers, whatever. Okay, there's a lot of numbers. A uniform distribution means that basically the probability of all these happening, so this axis is probability that this number is going to occur if all these numbers are basically, if I've got a bag filled with all these numbers, then the probability that if I reach into this bag, it's equally likely that any of these numbers will come out of that bag. It's a uniform distribution. All numbers are equally likely. So when you roll a single die with 6 sides, right, it is, so long as the dice is not weighted, it's equally likely that any of those will come out. Okay. The other distribution is a normal or Gaussian distribution, which looks like this, the bell curve, essentially. Or it looks more like this sometimes. Actually, this is the more classical bell curve. It's just harder for me to draw. Where basically that the middle value is more likely, and then as you get away from the middle, so this is like the way that height and weight are distributed among any kind of human population, right? So basically, if this was a lottery drawing, then there would be a lot more of the middle numbers than the numbers to each side. Okay, So that's all that means. So either everything's equally likely or the things are in the middle more likely. We're just going to deal with the normal distribution. That's the assumption, not the normal distribution, the uniform distribution. That's the default assumption for everything. Okay. Yeah. Okay, that's an excellent thing. All modules depend on the function random, which generates a float. So what this does is that it generates a number in the range from 0 to 1.0. Okay, that's all your computer's doing. It's generating a number between 0 and 1.0. Now, technically, there's an infinite number of numbers between 0 and 1.0 because you can always add another decimal point into that. But for computers, there's actually a space limit, 64 bits. So what it does is that it uses a special function called the Mersenne twister. That is literally it. The answer is magic. It uses something called the Mersenne twister to generate random numbers. It was developed by Makoto Matsumoto and Takushi Nishimura. And it's commonly used. Let's see, adaptation, disadvantages, state buffer, mediocre through modern standards, but it's useful. What it does is that, so it uses weird stuff. Matrix linear recurrence over finite binary fields, twisted feedback shift register. I don't understand any of that. That's fine. But the idea here is that typically what it uses is that it uses some kind of seed. It uses, it needs something to initialize it. So it uses a seed to initialize it. Now you can give it a seed so that your random numbers always follow the same sequence. This is useful for experiments if you want to reproduce something. But how do we get the seed? A seed value is used, and then let's see, come on, how did he generate the seed value? Typically what happens, the easiest way to get a seed value is to use something that's rather random, and the typical thing that's considered random is your system's clock in milliseconds or nanoseconds, right? The least significant digits of that are pretty random. Then we can use a couple of other weird things too, like maybe precision, or we could use things like where you are on the screen, but that's not actually too random because you're rarely here or here. But there's a number of things that you can use. All right, so it is actually, but generating random stuff is hard. If you're random, so random.seed, if you emit the seed, then the current time system is used. System time is used as kind of the starting point. So, because those last little digits in the time, the 1s and 10s digits in the time, are actually kind of really, are kind of really, there it is, randint. They're kind of really insignificant. So if I go random.seed, so I'm going to go random.randint. That's what I needed. So let's go ahead and see if so let's go ahead and run this. Do I need to provide a range? I think I do. So it says I need two arguments, A and B. I need a range. So 0 through 10. 7, 2, 3, 9, 7. It's not going to give me 10. It gives me 10, so it's an inclusive range. So, yep. It returns a random integer, alias for rand range, a b plus 1. So they have rand range, which is the non-inclusive one. Okay. You can also do random.choice, which will grab one from a list. But these are things we don't really need to know. Let's go ahead and say I want a number from, let's say I want a bunch of random numbers. Print. So let's go ahead and say L is equal to an empty list. And I haven't shown how to add things to a list yet. So this is also going to be useful. L is equal to, so for blank in range, let's go ahead and get 100 random numbers. L dot append. So this is how I add anything into a list. I say append, and this will just slap it onto the end of the list. Random dot rand range, and let's say I want a number from 0 to 100. So this will give me numbers that are between 0 to 99. So now if I print L, we got 2, 30, 64, 42, then 28, 89, 3, 51, 69, right? Completely random numbers. Let's go ahead and add some more digits, though, because I want to, you know. So these are all uniform and at random, so let's go ahead and actually make it a bit easier to read. So we'll just do 15 of these suckers, right? Okay, makes sense. Now, let's see. So, actually, so yeah. So that's how I print that out. Now, what does this have to do with justifying my text? Well, let's say I want to do this to, instead what I'm doing is, let's go with 0 through 10. And I want to append 10 to this power. So that way I've got all different powers of 10, right? Now, what I can do is that I can use right justify to basically make sure that they're all pretty even in one way or another, right? Blank in, so for a number in L, let's see what it was. It was string.r justify. Now, none of these are strings, but I can say num. I can take the number, turn it into a string, right? And now I can render it nice. R justify. Let's go with 20 characters. Oh, and I should probably print it because otherwise it's not going to do anything, right? Right? And now each of these takes 20 characters, and now they're all rendered properly. Right? But that's not all. I can also specify a second argument over here, which says, what would you like to justify with? By default, I'm justifying with spaces. I can also I can fill up those spaces that are justified with dashes instead, like that. And that's pretty cool. So I can render it like this. All right. Or I can render him with you know, the backslash character and just put it like that. So by justifying my text, I can basically fill it up. I can fill it up that way. Now there's a right justify, so obviously there's a left justify as well that works exactly the same way, only it puts stuff to the left, it evens stuff out to the left. But that's kind of the default way everything's printed, so it's less useful except if you want to fill stuff out to the left, right? If you want to print, have stuff to, you know, to the left like that. All right, so that's pretty cool. There's also a center, which center justifies, which is really hard to do normally. Like trying to figure right left and right padding, you could figure that out to do yourself. But it's non-trivial to do center justification, unless you're working in Python, which now puts everything in the center, which will center everything for you so long as you have a good string.
Why didn't you tell us about this before the ASCII art project?
I don't know. Yes.
Why does some of them have the breaks and the underlines with underscore while others are?
Because I have a font setting on that has ligatures and it's combining stuff. I can if I let's put in stars and see what happens. Right? It's combined when it sees 3 stars, it combines them like this. But it takes up the same amount of space. Or if I put X's like this, it's just a font thing. What? The 10, that just means how many spaces I want this to take up. right? If I wanted to take up 50 spaces, that's what it does. So that's how many spaces I want it to take up. And this allows it to like fill it up in a table-like manner. All right. So the last method is stripping stuff. So the last method is stripping things, which is basically removing text we don't want. So let's go ahead and use what we currently have. I'm going to take this, and now rather than, in addition to printing it out, I'm going to grab it and store, and I'm going to say, I'm going to put it in a new list. So rendered is equal to a new list. And then what I'm going to do is that I'm going to say this is, so right, this is me turning that random number into a string and then using the string function center to center justify it. I'm storing it in text. I'm going to print out the text, and then I'm going to add that to rendered. Rendered.append to add it to the to the list, right? To add it to the end of the list. Okay, so now I've got rendered, right? Print rendered, right? I've got all those lines stored in there. Now, suppose I'm coming into this later and I'm wondering why are there all these dashes in there? I want to remove all those dashes. Well, what I can use is I can use something called the strip function. So for item in rendered, I can print item.strip, and then you tell it what would you like to strip from it. By default, it's going to strip white space, but I can tell it to strip, for instance, the dashes. And if I do that, it removes all the leading and trailing dashes. So if there's dashes in the middle of stuff, it's not going to strip that. It just strips off the sides of it, right? It strips off the outer layers, right? If there were dashes in the middle, so if it was 1000-0000, it wouldn't remove that center dash. It just removes the stuff from the sides, right? Another example of this is spam hello space world, right? If you do spam.strip, which will remove the white space, it removes the beginning and ending space. There's also a left strip and a right strip, which just does it only to the left side and to the right side. Strip does it to both sides. So that's essentially it. I'm sorry you walked in right now because I have the unfortunate news of saying, and so now we're going to have a quiz over the stuff that we went over. So if you go to the to your quiz, so I'm going to go ahead and stop the recording for a second.